Okay, everybody, welcome back from lunch. Hope you're ready for this next session. We've titled this one, security and privacy in practice. We got a good set of talks here. Our first speaker will be Hala Assal. And I'm going to have to work on my glasses here. Let's see. Hala is a professor in the Systems and Computer Engineering Department at Carleton, and we're really pleased to have her here. Go ahead.
All right, thank you for the intro. Hi, everyone. I'm Hala. I am coming to you from Carleton University in Canada, presenting this work on system admins, vulnerability ownership, and remediation decisions. This work was done by my former MHCI student, Tamara Bondar, who unfortunately was unable to be here today. All right, so the motivation for this work is because security vulnerabilities appear in systems every day. They lead to revenue loss for organizations, reputation loss, and can also extend to users' physical safety. System administrators are often the only sole responsible for maintaining system security, in addition to all of their other responsibilities that do not necessarily include security. Previous work has looked into vulnerability notification campaigns, and we found that when the system administrators are aware of the vulnerabilities, the likelihood of them remediating it increases, but that is not necessarily enough. There's another line that looked at vulnerability management practices and how administrators coordinate information and tasks within and across different teams. And previous research also looked at factors leading to lacking remediation. For this paper, we're looking specifically at factors that influence remediation decisions for different types of vulnerabilities, and we're focusing on misconfiguration versus third-party vulnerabilities. And a second research question looks at how the creator of the vulnerability influences the system admin's remediation decision, whether it's themselves who created the vulnerability or someone else. And to do this, after a review of the literature, we created a preliminary interview study with system admins, and both of those helped us build our large-scale survey with system administrators from North America. For the sake of time, I'm only going to be talking about the survey today. You can read about both studies in the paper. Both studies were advertised as to learn about your duties, priorities, and factors that influence your decisions to avoid priming about security. The survey covered 12 topics: system administrator knowledge and previous experience with vulnerabilities, among other things. We also collected basic demographic information. We included attention check questions and technical questions to assess knowledge and ensure that we're recruiting the right demographic. We also included scenario-based questions to minimize bias, which I will talk about later. We recruited through Prolific and social media, which unfortunately was hit by a bot attack. So we had 702 responses from social media, and we had to manually go through those to clean the data. And we ended up with 124 valid responses, 50 from Prolific, 74 from social media. From our participants, 63% were employed in the US. The majority of them were men, and the majority had at least 3 years of recent professional system admin experience. Now, for the results, 61% of our participants deal with security vulnerabilities at least once a week, so it's a recurrent thing. 72% deal with security misconfigurations. A smaller percentage deal with third-party vulnerabilities. 70% would prioritize remediating third-party vulnerabilities over misconfigurations, and the rationale is that these are higher risk. Misconfigurations are less likely to be known outside of the organization. Approaches and complexities surrounding remediation is also different between misconfigurations and third-party. Misconfigurations require actions and efforts beyond the technical remediation. So the system admin would need to know the history behind the misconfig. They're also mostly hesitant to make changes to the work of others. Whereas with third parties, they mostly rely on support from the third-party vendor. So we gave participants a list of factors that influence decisions for misconfigurations and third-party vulnerabilities, and we asked them to rate their agreement on how influential they are for their decision-making. And if we look at the top 3 here, we find that the severity of the vulnerability and the system admin's skill and experience, previous experience with vulnerabilities, is among the top 3 in both misconfigs and third-party. The top choice for misconfigurations, though, is the skills and experience, because again, they depend on them figuring out how to fix the misconfiguration, and in third-party vulnerabilities, they mostly rely, again, on the vendor, or support from the vendor. We also looked at how the factors differ across organization sizes and across industry sectors. Unfortunately, I don't have time to talk about this, but we found some really interesting things there and encourage you to look about it in the paper. Now, to answer our second research question, who should be responsible for remediating vulnerabilities? And the quote we have here basically encompasses the sentiment: it doesn't matter who created it, it should get fixed. Most participants valued support from colleagues and mentioned that this would increase the likelihood for attempting the remediation. And the top of their strategies for misconfiguration specifically would be to start by reviewing the severity of the misconfiguration. Now, to dig deeper and explore participants' opinions of who should fix it, we created 4 scenarios, 2 for misconfigurations, 2 for third-party vulnerabilities. In all scenarios, we had an appointee system admin, someone who is temporarily managing the system or has moved away from that role, and they are the one who created the vulnerability. And we have a principal system admin who is the current system admin and the one that discovers the vulnerability. And we basically asked who should fix it. For both types of vulnerabilities, participants' least favored approaches were either the appointee or the principal would have to deal with vulnerability on their own, and they favored more approaches where there is collaboration between the 2 administrators. This is more significant in misconfigurations, likely because the principal system admin would still need to get contextual information from the appointee. So in closing, we see that remediation decisions are complicated. They involve risk analysis, cost-benefit analysis, which sometimes the system admins do not even have the skills to do. Some of them mentioned that they have formalized work review where more senior colleagues review their work. This can be useful, especially in misconfigurations which are unique, require the system administrator to diagnose the issue, identify possible solutions, and implement those solutions with least disruption to the system. They also talked about formalized documentation so that contextual information about configurations would be readily available for the system admin. This will also likely benefit SMEs. They are generally more skeptic of their skill and the training, as we've seen and other work has shown as well. However, this needs to be seamlessly implemented in the workflow to avoid stress and burnout. Now, the third-party vulnerabilities, participants seem to have a generally good experience collaborating with third-party vendors, so it would be interesting to explore this further. The most interesting part, at least for me, from that paper is how our participants exhibited that psychological ownership of their systems. They considered the principal system administrator as the one who holds the moral obligation as well as the work responsibility to keep their systems secure. Research shown that exhibiting psychological ownership improves motivation, which improves job satisfaction and also improves performance. So it would be interesting to see how we can devise tools and methodologies to support collaboration between system admins, building upon that psychological ownership, making sure organizations foster that sentiment, and it would also be interesting to see if that same sentiment applies to other domains as well. That's it for my presentation. I'm happy to take any questions.
Okay, thank you. And we'll take some time. We got several minutes for questions that you might have for Hala. was curious of, can you say something about what kind of organizations did these survey participants come from? Is it characterized in the paper, and any differences between them?
So we asked them of their organization size, and we divide them into SMEs and large enterprises. We also asked them about their industry sectors. So some of them worked in health services, some of them worked in IT companies, some of them worked in government, and so we divided the participants that way, and we did between subject testing.
Okay. And I was curious about your survey was attacked. Did you have some sense of what was the motive? Was this just
so there's compensation so we didn't have a pre-screening, and there's a compensation to the survey, and it's an online link on social media. So we didn't collect IP addresses because of ethics, so we didn't have that data. But Qualtrics has some measures that we were able to use, but those were not enough, and we actually had to go through looking for gibberish, looking for identical responses, looking for start and end time, which we would have like 10 responses that have the identical start and end time, responses that start and end at the same time. So we had to manually go through this and remove it.
Okay, let's thank Hala for her presentation. Thank you very much. So our next presentation is going to be by Anxhela Maloku. She's a recent MS graduate from Technical University of Munich. She's a UI UX designer, works on complex systems. She's really passionate about helping others design better and understand and integrate privacy considerations into their work.
Okay, so hi everyone. I'm here to present our paper from Technical University of Munich, Privacy Starts with UI. Without further ado, I'd like to actually dive in to how we bridged the gap, how this all started. And as many of you probably know, in the intersection of HCI, privacy, and development, well, there is a lot of research when it comes to dark patterns and all these patterns that are trying to manipulate users. So there's been a lot of documentation out there, and also proposals on like strategies that we should follow. A lot of guidelines and taxonomies, but the question that actually we got was this focus on the users. Well, yeah, but what about the designers? So driven by this, we sort of thought that shifting the focus not only to designers, but to UI, UX, and not only to the users, but to the designers as well, is really important to cover this little to no work that is out there on how to actually help designers to be in touch with more usable solutions and to actually apply that in their work. So driven by this, we kind of scoped our work into these three questions. Well, the first one, we tried to cover the privacy considerations based on the systematic literature review and the interviews that we conducted. And the second, followed by the same methodologies, we tried to cover and bring up the key factors that are influencing designers' work. And the third, which is also really exciting and also really close to the deliverable of all this work, to the catalog, is actually the strategies and approaches that could help designers to better integrate this into their work. So our methodologies, I mentioned a bit. The first one, the literature review, helped us to form all this groundwork. And then the semi-structured interviews, where we conducted interviews with experts in the field, mostly UI UX designers, but as well as few developers, to bridge this gap. And then the artifact evaluation, which followed with 2 interactive workshops, which I'm going to also talk a bit more later, and a follow-up survey. All this work finalized with the catalog that I will show. So the findings, I can't go through all the findings. you can all find those in the paper. But I will first cover a bit of this table where we present the privacy considerations that are grouped. The first group is understanding the people behind privacy decisions, because actually for designers it's really important to understand who is this target user group that we are designing for. And then, of course, in the design process itself, for designers, it's really important to understand and to have Figma files or like journey maps and other documentations and tools that can help them to bridge all these things into their process. And of course, to also have this more clarity in the discussions in between different groups within the departments of the companies. So the third one is, of course, about transparency and control, because we do want to offer to our users of what data are we collecting, why are we actually collecting, providing them some information of like how are we tracking and sharing their data too. And then the fourth group that I want to tackle is the ethical boundaries and legal compliance data discipline, because it's really important, again, to understand what is this sensitive data that we are asking, how we justify it to the user. And of course, the final one, which is like the top, is the legal frameworks sometimes are considered like as a really important thing when it comes to privacy, but how do we present this to the users as designers? How do we think of it? So then we grouped this into 4 axes, finding the key factors about designers. And the first one, which is really interesting, is designers really do care and really empathize with users. And they sometimes also have this friction when it comes to KPIs and other business requirements or clients they're dealing with. So there is also like a fear within the designers, like how do I actually present this to the users, and like the learnings that they have about making this information accessible to them. So the second one is, of course, we all know a lot, the communication in between the teams. And the privacy is like a shared responsibility, as I also say here. Sometimes, also I do have to say some participants, as I've mentioned in the slide here, they do consider privacy as like a hot potato, because in between teams, sometimes it's not clear flow, like where is design, like the privacy being started with and going to. So we really need to kind of integrate privacy from the early stages, and that's what our paper is also focused a lot in here. And also really important, like how is this cross-organizational culture dealing with these topics? And on the third one, as a designer, I do have to say that we do cover a lot of our work in like different checklists and systems and tools. For us, design systems are really important. So to include that work, we really need to have some framework that we can guide our work into. And then the last one, and I do have to say that the second one here from an interview was a really interesting discussion that I had with an expert in the field that mentioned that it's really not easy sometimes to deal with ethical questions, because they can so easily also become political questions, and sometimes even dealing with a clash of cultures. So it can be really pressuring for designers how to deal with all these. But that's why we present the catalog that is also like a product of all this research, and you have the link there to also navigate yourself in. This is like one of the early drafts that we did, and we present here 8 design patterns. We, of course, could not cover all the patterns out there, but our groupings are 8 of them, and we present here like a way of how designers can find themselves an easy, applicable, and also practical catalog with a Figma library as well, so that they can just reuse all these instances that we've created for the catalog. So we kind of bring theoretical findings in a more practical need of the designers. our artifact evaluation followed by actually presenting this work also during the interviews early on, and then iterated, of course, again through 2 interactive workshops where we evaluated our work and also contributed a lot to actually validate throughout all the stages of the research. And then we also did a follow-up survey to get feedback again based on the last iteration of the catalog itself. So I would actually like to also bring 2 conclusions of this work, because first of all, once again, privacy should start with the UI, because there is where all the work starts with. The design of a product starts with ideating and then also designing about it. So we should not leave designers later on in this work process. And also something really interesting is the hard reality that still many designers simply are not thinking about privacy. So this is actually a call to also other researchers to also shift more emphasis in this field and investigate more these pain points and what are these opportunities in this field, because it's really interesting how this has been out there for such a long time, but there is little to no work about usable guidelines. I'd like to thank here my supervisors, Alexandra and Stephen, who is also in the room, and Professor Matthes, who also helped me a lot during all this research and made this research possible, which was really great. And here is the link to our paper. You can again find there our catalog on the Figma library. I'm happy to answer any questions you might have.
Okay, thanks, Anxhela. We've got about four or 5 minutes, so let's think about some questions that you can, or discussions we can have with her to help advance this work. Maybe I wanted to ask a little bit about the workshops that you held. Can you talk a little bit about who attended those and give us a little bit more details about the results that happened there?
Yeah, it's actually really interesting. I think the workshops were really great value to the catalog because they were with practitioners in the field. So we really got insights from practitioners and basically how we could make this more in practical terms happening. And validating the artifacts that we started to create after the interviews in collaboration, and also combined to the systematic literature review. So yeah, experts from the field, but as well as simple junior practitioners to get all the insights from different samples.
Okay, go ahead.
Thank you.
Here, just a second. I think they're working on that. Just a second. Try it again. Try it again. Does it work? Here, I'm going to bring you this mic. Let's do this.
All right, thanks for the great presentation. So I teach about deceptive design to software engineering students, and one time, so they're not designers, I'm trying to get them to think more like designers. One time the students told me, well, if we don't do it that way, then the competition is. So we're going to lose clients. And these are people who take an auth to protect users. So what do you think about that?
So did I get it right? You said that the software developers are in the competition? Or
these are still students in a software engineering team, so they're not designers, but they do sometimes design UI.
Yeah.
And when we talk about deceptive design and the ethical implications of it, they're saying, well, there's all of these other applications, all of those other companies are doing that way. And if we don't build our applications that way, then we are losing on, we're losing.
Yeah, I got it now.
So did you see a similar sentiment with the designers?
Oh yeah, definitely. I mean, that was also one of the influencing factors of the designers' work, which I also mentioned. It's affected a lot by the standards of the industry and how actually the business requirements are based. And I think that goes very good alignment in what you said. But it has to start from somewhere, And I know that a lot of big companies are still kind of playing the ground for a lot of standards out there in the industry. But I think that there is a lot of good work, and I mean, I work with a lot of other designers, and I ask a lot of experts that have been in the field for so many years, and there is also really high interest to make this better. And I mean, that's also what this work is intending to do, to start from somewhere as like any other standard and regulation has started from, probably little to no work, but then making a big leap into the industry.
And just a short question to,
yes,
again, tied to our keynote, about the paradox. Did that privacy paradox, did that came out during the UX design? How UX design can have a corrective effect on the differences between attitudes and behavior?
Oh, once again, the attitudes, and I did not get the beginning of your question.
So the privacy considerations here were assumed as deterministic, as defined before, right? To what extent a concept of probabilistic privacy, or privacy that could end up in a paradox between what users want as privacy and what they actually do, came up as an idea, or how UX will kind of eliminate or alleviate that paradox?
Oh, that's a great one. You mean, so...
Okay, I don't want to make you like, okay, I just...
No. One of the discussion that has been really interesting is like how we actually inform the users about the data collection and so on. So that touches a lot of the thing that you're bringing up. And the discussion which I had with a PhD student was, how can we do this so that it does not backfire? So how we inform the user, what is the language we use, and how much we provide information to the user, such that this data collection informative way of us for designers to give to the user is not backfiring. And I think that plays a lot in like the language we use and the UI components that are also touched a lot in the catalog, especially in the regulation, like registration category. So right. I'd be happy for you to check that.
Oh yeah, definitely. Thanks.
Okay, thank you. Let's thank Anxhela again for
Thank you so much.
Okay, our next speaker is a remote talk. Someone couldn't be with us. This is a paper. Our presenter is Martin Turan. He's a recently completed master's at RMIT. He focuses on bridging the gap between software development and cybersecurity. He's exploring a PhD options. He's interested in those topics, as well as quantum computing. So we're going to have his video, and then he'll be online for some questions.
Hey everyone, my name is Martin. On behalf of authors, let me present our works with title When Security Meets Usability, an empirical investigation of post-quantum cryptography's API. This is collaboration between RMIT University, Muratua University, and ExaQuantum. First, I would like to talk about the background, why this is important. As we know, quantum computing threatens the foundation of today's public cryptography, such as RSA and ECC, will no longer provide adequate protection. NIST has warned that by 2030, this classic crypto system will be deprecated, and by 2035 it will be disallowed entirely. This risk is not purely feature-oriented. The harvest now and decrypt later strategy enables attackers to collect encrypted data today and decrypt it later. In response, NIST have initiated a rapid transition to post-quantum algorithms. To solve this problem, post-quantum cryptography algorithms like MLCAM and NDSS have been developed, and these algorithms are strong to resist quantum computing attacks. But strong algorithms alone are not enough. In real world, security fails not at the math layer, but at implementation layer. If developers misuse API, vulnerabilities persist regardless of the mathematical strength. Past research shows that many cryptographic failures arise from misuse rather than broken mathematics. A classical cryptography API, such as implementing TLS and SSL, symmetric and asymmetric encryption, demonstrated this repeatedly. Yet, post-quantum cryptographic APIs have not been empirically evaluated from a developer perspective. Therefore, this gap motivated our studies. So, we structured the study around three research questions. The first is, what usability barriers and misuse arise when developers use post-quantum cryptography API? The second, how do integration challenges differ across API architectures? The third, what design or documentation improvements are necessary to support secure implementation? This question guides both our experimental design and analysis. For the task design, our research focused specifically on the usability of PQC API functionality. This included key encapsulation mechanism, symmetric encryption, digital signature algorithm for handshake authentication, digital signature algorithm for message exchange. We want to examine how developers interpret the API, where they are struggle, and what cognitive load they face while they are implementing all these PQC functions on provided skeleton to make a secure communication. Most importantly, we want to understand how this challenge might lead to insecure implementation. Therefore, to ensure that the findings reflect real-world programming scenario, we employ a moderated remote usability study design. This approach maximizes ecological validity by allowing participants to use their own familiar IDEs, and we also allow them to use any tools they usually use when developing software, such as a search engine or even AI tools. Our study involving 16 volunteer software developer and IT students. The process began with obtaining ethic approval, followed by a screening questionnaire to identify qualified participants. Once the participants signed the consent form, we arranged a schedule for a remote online session. At the start of the session, participants were provided with a brief general knowledge and specific task guidelines. They then performed a programming task using a think aloud protocol, which was recorded for qualitative analysis. After checking the task completion, participants filled out a post-task questionnaire based on the cognitive dimension framework for security APIs. Finally, we conducted a true quantitative analysis and qualitative analysis of all collected data to identify the primary hurdles in PQC API adoption. And to answer the research question number 1, we conclude that first, participants struggle with overly low-level abstractions, requiring manual assembly of primitives. Second, documentation lack a workflow for explanation, and the terminology was jargon-heavy and inconsistent. The strict sequencing of operation forced premature decision and trial and error debugging, and also this factor increased cognitive load and lead to trial and error behavior, which naturally produces more mistakes. The usability issue on previous slide could cause security misuse and generate vulnerabilities. By analyzing the participant final code, we found several common security issues. One of the critical issues is that participants frequently mishandle sensitive data, such as exposing shared secrets and decryption keys. Participants also omitted implementation that fully adhered to secure lifecycle practice, such as a validation check and failing to destroy unused key. Specifically, this best practice is recommended by NIST guidelines. Regarding second research question, we identified significant difference between the two API architecture. The local library API allows for a simpler and quicker implementation for task number 1. However, it becomes more difficult for subsequent tasks, as it lacks high-level abstraction. In contrast, the web-based API provides higher abstraction. By combining the key derivation function and digital signature algorithm into a single key encapsulated mechanism function sequence, While some participants also struggle with the initial complexity of setup, such as managing authentication headers and the tokens. Those using the web-based API were faster at completing task number 2 despite being slower on task number 1. Statistics show task performance categorized by API architecture. The local API enables faster completion of task 1, whereas the web-based endpoint API simplified later steps. However, on both API, complexity accumulates over time. Critically, no participant completed all tasks, and indicating a considerable cognitive burden. And finally, for recommendation for resource number 3, we propose several improvements. The first, APIs should provide high-level secure by default workflows that encapsulate common patterns. And key lifecycle management should be automated when possible. And error handling should be mandatory, not optional. Next, we recommend it for developer-centric documentation. The documentation should outline the secure communication workflow between the client and server, by providing runnable examples that included error handling and best practices for secure key management. We also observe that both APIs still utilize traditional terminology and even ambiguous abbreviation. To improve clarity for developers who may not be security experts, we recommended adopting NIST standardized terms, such as by replacing public key with encapsulation key and private key by decapsulation key, while providing also clear definition for all technical terms. And to summarize, first, we found developers encounters predictable misuse such as key leakage and missing validation. Secondly, each API has its own benefits and weaknesses. Endpoint web-based APIs simplify some steps but introduce configuration overhead, whereas low-level libraries provide flexibility but increase cognitive burden. And both API require stronger usability guidance and safer defaults. In closing, mathematically secure algorithms do not guarantee secure software. If developers cannot correctly use the PQC tools, migration efforts may fail in practice. Therefore, usable security must accompany post-quantum cryptography. Thank you.
Okay, let's see if we can. Hi, Martin. Can you hear me okay?
Yeah, I can hear you.
Okay, good. Thanks for being online. Let's see if we have any questions for you. So I enjoyed hearing about this talk in my own group. We did some work with TLS about 5 years ago, and I saw some interesting sort of repeated patterns. I agree with your recommendation to make higher level abstractions. And I'm really curious about your last recommendation that we really have to make this available for the generalist rather than the cryptographer. So do you really think that the general programmer is going to have to encounter APIs that use quantum cryptography? Can you give some examples of how that will occur?
Yeah, thank you. Especially when I'm talking about the generals, we are talking about in the student level, especially like they are still in the IT student, but they haven't yet to like what to. They're still building their website. They are still building what they want to do. But actually, in the developing in this part, the experiment, there is not available TLS API itself. Actually, hopefully, so they have to build it from the scratch from the using the cryptography API first.
Okay. And I saw in your study you had some students, and then you got developers. Were these industry developers, or tell me how did you recruit them, and who were they?
Yeah, actually, it's using snowballing, and we are distributing some Slayer. We are distributing also in the website. So we are recruiting them from our professional network, we are using our industrial college, like from Exaquantum. They trying to recruit some professional developers too.
Yeah, and do you have any plans? Are you going to do some future work on this topic, or what are you going to try to do to get these? Who needs to hear these recommendations? Who could act on these? Are you making any efforts to?
Yeah, actually, our partner AX Quantum is made one of the API that we are doing the experiments. So we hopefully for the next experiment we could put more accessible, more usable APIs for the post-quantum cryptography and building it more so like a lot of people, a lot of developer could use this post-quantum cryptography API to migrate to a new standard for this cryptography.
Okay, thank you. Any more questions for Martin? So thanks so much for being with us, Martin. Let's give him a final thanks. And go ahead, our next speaker is Ravi here. Yeah. Okay, can you talk? Yes. Yeah, I'll do that. Okay, our next speaker is Ravi Mahankali. Maybe he'll correct my pronunciation there for you. Oh, and let me. So Ravi's a second-year PhD student at University of Bristol, researching usable privacy and security tooling.
Hello all. I'm Ravi Mahankali, a second-year PhD student in the University of Bristol, supervised by Professor Joseph Hallett. Before going into the presentation, let us quickly understand what differential privacy is. Organizations want to extract value from sensitive data sets while limiting the risk of exposing individual privacy. Differential privacy is a framework that promises mathematical guarantees, and it provides mathematical guarantees that individual data cannot be identified from data analysis outputs. And yet, its adoption outside major technology companies remains very low. We wanted to understand why. We analyzed 2021 GitHub issues reported by real developers from 5 major differential privacy libraries to find out what's going wrong. So why does this matter? Why does this study matter? Differential privacy is one of the strongest mathematical frameworks we have for protecting individual privacy in data analysis. But here's the problem. If developers can't use these libraries correctly, poor usability can lead to implementation errors that directly compromise the privacy. So these tools are to provide the guarantees of kind of privacy, but then if the usability of these tools are not proper, obviously it is leading to compromised privacy of the individual data. A misconfigured parameter value or an incorrect API call doesn't just cause a bug, it can silently leak private information. Let me show you some examples. You can see here on the slide. It looks like in practice when implementing differential privacy, there are quite some issues that a common developer would be kind of coming in contact with. On the left, we have 2 real GitHub issues. The first, a developer passes a privacy parameter. It's called epsilon, and the value he's passing is equal to 0 to Google's differential privacy library, and the function fails with no helpful guidance. The second example, bounded functions silently overflow on large data sets, returning the lower bound instead of the actual result. No error messages, no warnings. The data is just wrong and privacy may be silently compromised here. These aren't just edge cases, they represent the most common class of problems that we have found. Our study addresses 3 research questions. Research question 1, what usability challenges are developers actually experiencing when using differential privacy libraries? Research question 2, are these challenges the same across all the libraries, or does each library have a distinct usability profile? And research question 3, are the usability issues for differential privacy different from those faced by users of other privacy-preserving techniques like cryptographic libraries. For our methodology, we have extracted 2021 GitHub issues from the 5 major differential privacy library providers, IBM, Google, and different other providers, between the years 2020 and 2025 using the GitHub REST API. We developed a 14-category codebook from our dataset. 2 independent coders have coded this, and we have achieved a coherence kappa score of 0.87, indicating strong intercoder agreement. We then applied mixed methods, chi-square test, correlation analysis, and thematic coding to analyze the data. And here you can see some of the examples where the developers speak for themselves. We analyze the issues reported on GitHub by the developers, where they are speaking for themselves. In this issue reported, a PySwift user seems helpless, asking for an example of how to train a neural network using the given library. Here, in this example, a Python developer is getting Rust-based error, which is kind of typical to not get in a Python-based library, which is an OpenDP library that we are presenting here. So it's an entirely different programming language, and the error message is in a different language altogether. Here, an IBM differential privacy user is confused about why epsilon values, or the privacy parameter values, up to 10 million don't seem to affect model accuracy, which also means that it is unable to address some fundamental misunderstanding that some developers may have. Example notebooks in the documentation that give completely different results than what's documented because the API has been changed a few years ago. So this is an example of unkept documentation. So that's one thing that we need to address. Now coming to our main findings, the top 3 usability challenges account for over 62% of the issues that we have collected, and API misuse dominates at 31.5%. Developers are using wrong parameters, making incorrect method abstractions or incorrect method calls, and struggling because library abstractions don't match their mental models. Example code requests come second at 16.7%. Developers need concrete, runnable code, not just theoretical documentation. And usage guidance questions at 14.1% show developers asking, how should I use this? They can't figure out which approach to take for their specific problems. The full breakdown of all the categories is shown in our paper, so I recommend to please give it a read. Going a little deeper into what is observed, the biggest usability smell, that is 31.5%, which is API abstractions. As you can see, developers pass reasonably looking parameters, and they get very cryptic errors sometimes, or call methods they expect to exist and hit attribute errors. The APIs just don't match how developers are thinking. Second usability smell at 16.7%, a user asking for a working example is left with no response, unfortunately, on this GitHub issue that he has reported. An example notebook giving wrong results because the API changed years ago. Developers ideally learn by doing, and when examples are missing or broken, they are stuck. So another one, which is usage uncertainty, which is again, it relates to decision paralysis. One developer asks how to pick max contributions dynamically in this example, and another asks the library to mirror familiar data science APIs so that they can just use the same flows that they are used to rather than kind of completely changing the way that they think about. They're not confused about the differential privacy mathematics from what we observed, but they just can't figure out which feature to use exactly. And this is one more important thing, about 0.9%, but the most dangerous. One user has no intuition on setting the parameter value. Another sets it to 10 million or whatever indefinite amount of the value the privacy parameter allows. And unlike the crypto libraries, wrong differential privacy parameters don't crash, but they silently leak the privacy. This is where usability features become privacy breaches. For our research question 2, we tested whether all libraries face the same challenges. The answer is clearly no. Libraries with different design philosophies have different usability issues. And this means one-size-fits-all usability improvements won't work. Each library needs tailored solutions based on its design philosophy. For our research question 3, we compared our findings with prior study of cryptographic libraries and differential privacy libraries, which is like we have compared some of the privacy-preserving methods that exist, and the differences are striking. These findings tell us whether we need specialized solutions for differential privacy or whether general-purpose privacy library usability guidelines would suffice. The bottom line is differential privacy libraries face fundamentally different challenges than crypto libraries, and need for specialized usability approaches are imminent. For a more detailed analysis of the comparison, I'd again recommend to please read our paper. Based on our findings, we propose 6 recommendations. Interactive notebooks so that developers can experiment in browser. Parameter visualizations showing epsilon delta-like parameter trade-offs in real time. Contextual error messages instead of raw Rust errors or errors which do not immediately help the developers understand what's going wrong. Layered documentations from beginner level to advanced. Type-safe interfaces that prevent misconfigurations, and CI pipelines that catch stable examples automatically. To wrap up, 4 key takeaways. API misuse dominates. Differential privacy library abstractions fundamentally fail to match developer mental models, and this is #1 barrier. Each library has a distinct usability profile, so improvements need to be tailored rather than generic. Differential privacy libraries face conceptual barriers, not technical ones, unlike crypto libraries, where installation was observed to be one of the main struggles, as per Patnaik et al.'s study in 2019. And perhaps most importantly, these usability challenges have remained stable for differential privacy libraries from 2020 to 2025, meaning incremental fixes aren't working, and they need to be addressed at the root level. We need to fundamentally rethink about the differential privacy library design rather than just fixing things as and when they're reported. Thank you. I'm happy to take any questions.
Okay, thank you very much. We've got about 3 minutes for questions that you have for, let's see, very interesting. I don't know whether that's a depressing, seems like a depressing situation we have right now. Maybe I have 2 kinds of questions. My first question would sort of be, well, so who needs to change the most? So do we need it, is it the developers and correcting their mental models? I mean, so is it primarily the people problem that we could largely solve it by? Is it all the burden on the cryptographic libraries need to adapt? What, both? What's kind of your high-level sort of sense?
Absolutely. I mean, again, we have gone through previous studies done both from other privacy-preserving technologies like crypto or kind of other DP studies as well, and we have observed that there are things that are recommended for kind of improving the library, but the main problem that is actually existing is 2 ways. One is like, do the developers really understand the concept of differential privacy, for example, and then for making it easy for them to understand what are the things that must be done, which are some of the recommendations that we have tried to provide in our paper. So I think there is a 2-sided problem that we need to address.
Okay, yeah. So I have a question. Do you have a question? Yeah, please.
Hi, thank you so much for the nice talk. Actually, I had the similar problem. Like 2022, I was using like differential privacy library, and after 1 year, I saw that they updated the PyTorch, but forgot to update the differential privacy library with that, so there's a lot of problems. So my question is, like differential privacy is popular for so many years, and you have showed that from 2020 to 2025, there was not much improvement. Like in your study, what do you think, like what is the reason that it's a popular topics, but still in terms of libraries on developing stuff, specifically I felt also that like in terms of documenting stuff or upgrading stuff, there's a lot of gap. Like, what do you think that the big companies like that, they're kind of not doing that, as that is for a
I understand
long
your
time.
question.
Yeah.
So the thing is, I think the reason why the adoption is a little lesser in the market is because conceptually it is really good. 100% accuracy, whatever that it can provide, 100% promises of preserving the privacy. But unfortunately, it is not easy to translate in terms of a regular developer's ecosystem or an environment, because say for example, if a developer is just doing data analysis using simple Python programming, and they are like, okay, this is where I live, I have my core understanding of how data analysis works, but when they add this additional privacy libraries, they're like, okay, this comes with more parameters, more difficulty to adopt, more things to learn about, and because that abstraction is not being met from the developer's point of view, they're like, it's difficult for me, and I prefer not using it. Rather, use cryptography or other things which are much more easier for them to implement in programming point of view. So that is where we are suggesting to kind of improve things from these are the recommendations that we are providing, and asking the library developers, okay, to kind of take these recommendations and try to improve in terms of adoption.
Thank you so much.
Thank you.
Okay, thank you. Let's thank Ravi.
Thank you so much.
Again, thanks for your talk.
Thank you.
Okay, we have our next talk is, we'll have another remote speaker on video. Masume Shafinijad is an ML scientist at Vector Institute. This is one of three Canada's national AI institutes. Works on developing privacy-enhancing technologies. Received her PhD from the University of Waterloo, Canada in 2021 on data protection in big data analysis. So go ahead with the video.
Hello, my name is Masume Shafinijad. I'm an applied ML scientist at Vector Institute in Canada. I am presenting our paper titled Adopt a Pet. This was an exploration of pets, policy, and practicalities for industry in Canada, done in collaboration with Dr. Ji Hay and Dr. Bailey Kashmir. I'm going to give a little bit overview of privacy regulations in Canada that motivated this work. Then I'm going to introduce the research questions that we had in mind and the survey that we came up with to answer these questions. And I'm going to talk about the results and some themes that we found in the survey responses, including the relationship between industry and regulations, pets adoption facilitators, and decision-making progress about pets adoption in industry. And then I'm going to talk about the key findings by stakeholders and the recommendations that we have for different actors in this multi-actor environment before concluding this work. Now, in Canada, we had PIPEDA as a federal privacy law since 2001. It was improved over years. But then in the recent years, there were conversations in the parliament about replacing it with C27, which had multiple acts, CPPA included, to replace PIPEDA. It was supposed to modernize privacy protections of the regulations. Now, this bill did not end up being enforced, but nonetheless, it motivated our work, and it made us think about this question that if privacy regulations would influence or encourage the adoption of privacy-enhancing technologies that I'm going to use as PETs for short in this presentation. We also had these other questions that what are the barriers that industry perceives that prevents them from adopting these technologies? And to understand that better, to start with, what are the common practices that industry have with regard to sensitive data and pets? And how do they determine at the end if they're compliant with relevant policies or not? Now, there were a number of findings in this that I'm going to talk about after the introduction of the survey. This survey was done among the industry sponsors of the two institutes that the authors were affiliated with. the Vector and Amy Institute. These are 2 of 3 national AI institutes in Canada. We emailed to the industry sponsors that covers a diverse set of Canadian organizations from finance, telecom, consulting, and so on. We ended this survey when we reached saturation by 22 participants, and we saw the reoccurring themes in the responses. Now, the first thing to explore was the industry and regulation relationship. We noticed that there is a lot of confusion in understanding the regulations by government for the industry practitioners. They have difficulty in figuring out what is relevant to their use cases and what is not, and more importantly, what are the methods of complying with those regulations. There is a constant monitoring from industry for guidance and reports from maybe unofficial resources, and they rely heavily also on consulting with appropriate experts to understand this field better. Now, on PETS adoption facilitators, I should mention first is PETS functionalities compatibility for sure. The adoptability of PETS to the different systems and frameworks that industry has and how well it integrates, how learnable it is or usable it is, has a huge impact. But also what was, to our surprise, a new factor was also industry's socioeconomic system. So first of all, how it fits with the business logic. Does it help with the position of the industry in the market? Are there ways to validate the solution and audit this? And does it help with client demands and all that? I will touch on more in the next slides. And overall, like how it wins in this cost-benefit evaluation. Now, PETS adoption decision-making varies across industries. It really depends on the type and size of the company. But we found these general common themes and the steps among this process from the monitoring the need for PETS to approval. So there are multiple departments involved in that. There is validation done by looking into if it helps with compliance, if it helps with the market positioning, or if it addresses a certain risk. What I would like to particularly emphasize on is in exploring solution, what's important is like who is using the solution, who is making it, and who is recommending it. That shows that how environment also affects this process. And then in evaluation, there is a need and wish for verification or standards that we don't have currently. And if it helps with safeguard and defenses before it gets to the approval. There are varied practices like mechanisms for privacy protection. It doesn't necessarily always include privacy enhancing technologies, but also I want to mention this, that in the privacy enhancing technologies that our sponsors or the industry participants mentioned, there are mentions of commonly used PETs like encryption, access control, and password management, but there seems to be a lack of awareness on state-of-the-art privacy-enhancing technologies. On compliance verification, we also noticed that there is a lot of confusion on how to verify if the technology helps with compliance or not. And all in all, this gives us this understanding or like this messaging for different stakeholders in this field. For regulators, if the survey can have a recommendation, is that since the industry is finding the government resources to be challenging to use and understand, because they're using or engaging with unofficial resources to have a better understanding of the regulations and compliance, we would recommend the regulators to also engage with these intermediary parties to offer guidance with actionable insights. Now, for industry, we did notice this lack of awareness on emerging pets. I mean, we noticed that this is not mentioned in the responses, so we do associate it with the lack of awareness, especially among the decision makers. So, for example, like one of the topics that were mentioned a lot was on anonymity and the identification, which is also a pillar in a lot of privacy regulations, but then the methods or practices for satisfying this requirement varies a lot, and there is a lot of confusion if it's enough or what level of compliance this would bring. And this also is reflected from the regulator side, the previous research has shown. So what we are recommending here is this active communication with researchers, so that well, first of all, there's awareness of the common new pets and how they can help with compliance, which brings us to the researchers and the recommendations that we have for them. First of all, pets compatibility and integration with the systems that industry has in use helps a lot in pets adoption. But also what's very important is with pets verifiability and compliance. We don't have standards at the time, but if there can be recommendations on how to verify this pets, what's the level of privacy that it can bring, and if there can be any help in bridging this with the compliance, that would be very helpful to industry. And also, like in general, developing these privacy evaluation solutions would be a great help to industry. We also want to relay this message to researchers that understanding market dynamic can also help them with getting their solution have an effective propagation in industry, because we realize that the industry relies heavily on the existing service providers, and if they want to look into privacy and security additions, they see if they're integrated with the existing solutions. So that's something that researchers might want to keep in mind. And with that, I would conclude with this, that privacy is this unique, dynamic, multi-stakeholder environment, and it has so many socioeconomic system elements involved as well, in addition to the technicality of the solutions that matter. There are regulations, client demand, consultants, competitors, best practices, market position, and reputation that all matter to industry. These different parties have interdependencies in common pain points. One of the things that I mentioned was compliance verification. There is a confusion on industry that what helps in what with compliance in what level, and there is that also reflected by regulations that in the practices that they see, which one of them brings how much of privacy. There seems to be a lack of awareness of state-of-the-art pets in industry, and for sure future research needs to be done to understand where do these best practices emerge, all these unofficial resources that industry relies on in compliance and in technology adoption. And of course, an important question is, how is all of this affected when we have AI, and how that affects the privacy concerns? With that, I would like to conclude this presentation, and thank you all for attending this. I would love to hear from you. Thanks.
Okay, thanks. We've got about 1 minute for questions, if someone's got a question. Hello, thanks so much for joining us. Thanks for that talk, and we've got a question for you. Go ahead.
Hi, thanks so much for the amazing talk. I have 2 questions. I don't know if you have time. So first question is, did you notice if pets adoption is mostly reactive or proactive? By that I mean whether some breach happened or some other competitor using it, so they need to use some pets, or it's more proactive, like they are actively thinking about the harms and then they are trying to minimize that. The other is, when they want to evaluate some pets, how often have you seen anything like misalignment in terms of how the research community is envisioning some threat model and proposing some pairs versus what the practitioners or developers actually need?
Right, those are very good questions. I would answer the first one, how reactive they are and how proactive they are. I should say that what they mentioned in the survey is that they have this monitoring for need for the risks that they do foresee, but also they have this definitely like monitoring for the risks that has happened. So I would say that it's both of those that we've seen in the survey. And I would also want to say, like anecdotally, from my experience working at Vector Institute, being a research institute that tries to gap between the researchers and industry, we've also seen that. There's both of those. For your second question of, oh, sorry, I forget. Can you remind me, what was the second question?
Can you just summarize that question again for us?
Yes, so the second part was what they need, the practitioners, what kind of protection they need versus what the community is proposing now.
Yes, yes. Or like, what's the discrepancy between the two? We have noticed discrepancy between the two. Like, for example, for anonymity is one of the things that I mentioned in the talk also, like the practices that industry goes with ranges from like just removing the names or removing somehow the correlation between the data to the use of synthetic data at the end. But then, like, in privacy community, we do not consider just removing the names to be a privacy protection at all. That's actually a no-no in privacy community. And even in the use of synthetic data, I want to say that we are trying to have this conversation with industry to clarify that only the use of synthetic data, the pure fact of that doesn't mean that it's just fake data and it's like 100% privacy preserving. So this is something that is well known in research community, but then in industry, it is not as much known. So we have to convey this message and clarify it that even if it's synthetic data, because it's generated from original data and it tries to capture the trends and patterns in the original data, and somehow sometimes in the process, it also captures more than that, and it memorizes the original data. And there are ways that we can evaluate that leakage, and they need to evaluate that privacy leakage and control it so that synthetic data is privacy preserving. But it is something that we noticed that there is this misunderstanding in industry, while it is a clearer known fact in research community that synthetic data, for example, is not totally like 100% privacy preserving by itself.
All right, thank you so much for the questions, and thank you, Masume, for being with us, and thanks for your talk. Let's thank her again. Okay, our next speaker is Alexandra Lee. She's a third-year PhD student in societal computing from Carnegie Mellon, and we're glad to have her. Thanks.
Okay. Hello, everyone. I'm glad to present our work today on evaluating user-centric threat modeling taxonomy for privacy notice and choice. So privacy notices and choices, such as like privacy policy, cookie management pages, data sharing controls, are known to be hard to locate. They contain legal jargons that are difficult to understand, and they're also not easy to use for an average user. Meanwhile, privacy and data governance regulations are imposing stricter regulations on how data practices are disclosed and what types of data controls should be offered to users. So for example, Europe's GDPR regulates that consent must be given freely and informed, and CCPA regulates against manipulative fact patterns in privacy notices and choices. So in order to both fulfill these legal requirements and also provide their customers with more informative privacy notices and usable controls, organizations are looking for guidance to help them identify, document, and mitigate privacy threats. And there are existing privacy threat modeling frameworks that help identify privacy risks. However, they tend to primarily focus on analyzing data flows rather than centering on the user-oriented aspects. So to address this gap, we developed the Users First framework over the past few years that helps analysts uncover user-centric threats in privacy notices and choice mechanisms. The first version of this Users First framework was published in spring 2025, and it has been since presented at venues including IAPP and Pepper. this is our home website to the Users First framework, where you can find more details on the framework and how to use it. So to summarize, the framework has two main phases. The first is a design phase, and the second is an analysis phase. So the threat analysis phase includes a taxonomy of 28 user-oriented threat types, grouped into 4 major threat categories. The first is discovery of use. The second is comprehension, which mainly address with whether a choice and a notice is easy to understand for a user. The third is appropriate choice, which relates to the type's granularity or modifiability of choices. And the fourth is manipulative elements. So for this study, we're evaluating a version of 0.9 of the threat taxonomy, and the taxonomy has also since been updated, and the current release version is version 1.1. So here is one of the example threats that we have in the Users First taxonomy. For each of these threat types, we have a definition for the threat, some evaluation questions that help you decide whether a threat exists, and we also have examples of how this threat can demonstrate itself. So in order to evaluate the effectiveness of Users First taxonomy, we conduct a 90-minute experiment involving 26 participants. And these participants are either people who have professional experience in privacy, or they have received graduate level degree in privacy. And in these experiments, they were randomly assigned to either using the Users First taxonomy or not using it. And we asked participants to basically review scenarios to identify user-centric privacy threats and compare between the performance between the group using the taxonomy and the group not using it. So our work mainly revolves around 2 research questions. The first is like whether the Users First taxonomy actually help practitioners with, to do a better job identifying threats. And the second is in what areas does the taxonomy best assist them, and in what areas is there room for the taxonomy to be improved. So to facilitate our evaluation of the Users First taxonomy, we designed specific scenarios involving 2 fictitious products, each presented in the form of a set of storyboards showing a user persona, Chloe, which is shown by this AI-generated woman here. And the storyboard shows her using the fictional application or device to perform a series of privacy-related tasks involving notices and choices. So the first scenario is a mobile application for an eyewear retailer, which we refer to as the AcroFrame scenario. And the second scenario is a smart TV scenario, which we refer to as Beyond scenario. So I'm going to take the AcroFrame scenario, for example, and you can check for more details on the Beyond scenario. So for this AcroFrame scenario, basically our user persona, Chloe, she uses the app to shop for eyeglasses and use the virtual try-on feature to see generated images of herself trying on the glasses. Yeah, this is one screenshot from our Beyond scenario. And back to the AcroFrame scenario. So basically, this virtual try-on feature required Chloe to consent to the collection of her biometric data in order to perform the face scan. And in the later process of her using this app, she attempts to withdraw this consent that she has given to allow the app to access to her biometric data, but she eventually failed to withdraw the consent. Yeah, and these scenarios were developed by integrating elements from real-world systems while maintaining a level of threat intensity that's comparable to the system that a user will typically encounter in their real life. So we made minor adjustments, including like removing certain problematic elements and introducing others to cover a larger portion of the taxonomy threats so that we can better evaluate the effectiveness of the Users First taxonomy. So here is one sample pages. It's a cookies management page that we include for the AcroFrame scenario. And in this page, we include a total of 4 taxonomy threats. The first is too much effort to access this page. So basically, Chloe tries to withdraw her consent of her biometric information. And it took her 6 clicks to arrive at this page, which is not even relevant with biometric data. The second threat that we include is this tags that's included in this cookies management page, but it's containing a lot of legal and technical jargon that's hard for users to understand. So the third threat that we include is visually manipulative design, which is using the gray color to show active toggles. And the fourth is less privacy protective defaults, which is having this cookies on by default. So regarding our experiment, we recruited a total of 26 privacy practitioners who are also likely the population most likely to use the users for taxonomy in their professional settings. And these participants were assigned to either with taxonomy or no taxonomy condition, and then to one of the two scenarios. So for the with taxonomy groups, we provided the participants with the taxonomy and also instructions on how to use it. And for no taxonomy participants, we asked them to explore freely or use a framework that they brought if they prefer to. And we're doing this to simulate what they would normally do in their work settings. So for data analysis, we first established a ground truth of threats by having 4 members of the team collaboratively review the 2 scenarios to identify threat instances using the users first taxonomy. We identified a total of 17 threats for accurate frame scenario and 22 threats for beyond scenario. And for each threat recorded by participants, we determine whether it is relevant in the sense that whether it's like a user-oriented privacy shortcoming of one of the specific notices and choice we asked them to focus on during their analysis. And if yes, we map it to the corresponding ground truth threats. We compute the recall, which is the percentage of total ground truth threats identified, and the precision, which is the percentage of the unique privacy threat instances reported by a participant that were relevant. So this is a brief description of part of our result. The darker bars are participants who are assigned to using the users first taxonomy, and the lighter shade bar are people who are assigned to explore on their own or use any framework that they brought with them. The x-axis are the strat categories and the scenarios participants are assigned to, and the y-axis is the percentage of threats percentage of ground truth threats that they were able to identify. So basically, we found that the WIS taxonomy participants had a significantly higher average recall compared to no taxonomy participants, and that is the case for both scenarios. So in the accurate frame scenario, we find that the participants in the WIS taxonomy condition, they identify about twice as many ground truth threats compared to those in the no taxonomy condition. And we observe a similar pattern for beyond, where the WIS taxonomy group, they identify roughly 50% more ground truth threats compared to no taxonomy group. We also found that taxonomy made participants less likely to miss an entire high-level threat category. Specifically, only 2 participants in the WIS taxonomy condition missed 1 category, compared to 11 participants in the no taxonomy condition who missed at least 1 category. So some of the major takeaways from study. So apart from observing the fact that users first taxonomy help practitioners identify slightly more relevant threats, we also find that it supports practitioners in a way that allows for people with very experience to use the framework. So we found that participants with prior threat modeling experience, they tended to take a scenario-centric approach, which is quickly connecting identified threats to corresponding taxonomy types and using the taxonomy as a checklist at the end. Less experienced participants, on the other hand, they relied on taxonomy from the start in a more time-consuming manner, but they were able to work faster as they became more familiar with the taxonomy. So our study gave us real-time insight into how participants use user-first taxonomy, which help us identify areas for refinement. For example, we found that participants often recognize the threats, but misclassify them when they're using the taxonomy, usually due to like subtle confusion between definition of similar categories, suggesting that the taxonomy may be too granular and certain threat types could be combined. We believe that this work also demonstrated how to evaluate a privacy threat taxonomies from constructing realistic scenarios to design targeted threat identification tasks under an experiment setting that we can have certain control over what are the threat types the participants see. And we believe that this evaluation method can be adapted to access other user-centric privacy tools. So lastly, I would like to appreciate our sponsors for funding and supporting our research. And if you have any questions or if you want to see more details on this first taxonomy, you can go to our website where you can see different versions of the framework and also more instructions on how to use it. I'll be happy to take any questions that you have.
Okay, we've got time for just a short time for one question. If anybody has a question for Alexandra. I just had one question about the methodology. So if I understood it correctly, some of the participants had that taxonomy that they could learn from this users first, right, as they're doing the evaluation. So they kind of did in quick proximity. Is this the kind of thing that you would need? You'd expect someone to have this with you every time you go to do this kind of a task? Do you think these are also what would change if you had reviewed this and some time had passed before people were able to use it?
You said like, are they able to like get familiar with taxonomy in a short period of time to be able to use it?
Yeah.
Yeah. So I think according to our result, they can, and even like some of the participants did say that they wish they have the taxonomy prior to the experiment to get more familiar with it. But because we want to have everything like happen in a control setting, so that we can observe the process that they get themselves familiar to taxonomy and like what are some of the areas that's easier for them to get familiar with and what are some of the areas that seem confusing. So that's why like we have everything, like this entire process of them familiarizing themselves to happen in that 90 minutes so we can like have real-time observation of how they actually familiar themselves with it.
I see. And then you said you did 90-minute experiments. You know, that's a long experiment. You know, we sometimes worry about fatigue. Did you see any effects of that? Did they all take 90 minutes? And
yeah, I think
that was a long
all of participants take the entire 90 minutes, especially the people who have been given taxonomy, because like for all of them, it's like the first time that I see it. So, but I think they really get involved in the process because after they're familiar, right, with it, they feel like it's like a good tool to use, and I feel like it's still like an interesting stack for them to go through the scenario and try to identify the threats. The people who don't have the taxonomy, they tend to spend less time because they don't need to get familiar with like a framework, and they can just like explore on their own. So yeah, I feel like 90 minutes is definitely a long time, but we feel like it's like necessary for them to actually have the time to review the scenario and also review the taxonomy. Mm-hmm. So yeah.
Okay, thanks. Okay, let's thank Alexandra again. Thanks for your talk.
Thank you.
Okay, our final speaker in this session is a remote presentation. So we've got a video to show first, followed by some questions. We got Nicholas Busch. He's a PhD student at CISPA in Germany. He really wanted to be here and felt, but I'm glad we can see his video and then maybe have a question or two for him when he finishes. So go ahead with the video.
Hello everyone. My name is Nicholas Busch from CISPA, and today I will present our paper From Paranoia to Compliance, the Bumpy Road of System Hardening Practices on Stack Exchange. This is joint work with my colleagues Philipp Klostermeier, Jan Klemmer, Yasmin Ajar, and Sascha Fahl. System hardening is widely recognized as a fundamental security practice. It is intended to reduce attack surfaces, eliminate misconfigurations, and prevent adversaries from gaining unauthorized access. But in practice, several incidents continue to occur. Recent breaches illustrate this clearly. Misconfigured cloud storages expose sensitive data of tens of thousands of organizations, or stolen signing keys and improperly configured services led to large-scale compromises. And even well-established companies suffer data breaches regularly. These examples demonstrate that system hardening is challenging in practice. Inadequate or missing system hardening remain one of the dominant root causes of security incidents. And furthermore, in some cases, system hardening is required by law. But yet, we lack a comprehensive understanding of how system operators actually experience hardening in real-world contexts, and no studies focus on real-world operator motivations and challenges. So in this study, we asked the following 3 research questions. First, what are common system hardening areas? We wanted to identify the domains and security aspects that are most frequently discussed when operators talk about system hardening. Second, what are drivers for system hardening? We aim to better understand what drives system operators to strengthen their system and application security. And third, what are challenges in system hardening? We are interested in identifying the most pressing challenges for system hardening. To answer these questions, we conducted a qualitative analysis of 360 Stack Exchange posts related to system hardening. We used Stack Exchange RP to collect posts either tagged with hardening or containing hardening or harden in their title. We only used technical communities and wanted to exclude outdated content, so we focused on the past 6 years. We applied semi-open qualitative coding and iterative codebook refinement. After finishing the coding, affinity diagramming was used to identify higher level categories. Let me now turn to the results. We were able to identify 6 main domains. Due to time constraints, we only focus on 2. The largest domain was operating systems, accounting for 43% of the posts. These posts mainly focused on Linux. The second largest domain were server applications with about 29%. The most frequently asked questions in this domain were about web servers such as Apache or Nginx. This distribution already tells us something important. System hardening discussions are still strongly centered around operating systems and traditional server applications. Even in a cloud-dominated era, OS-level configuration remains central. Next, we want to take a look at the security aspects. We were able to identify 7 security aspects, and we will take a closer look at access control and guidelines and benchmarks. Access control posts were the second most common. Many operators had difficulties in understanding concepts such as permissions on Linux. Questions about guidelines and benchmarks appeared in nearly 1 out of every 5 posts. Most of these questions referred to common guidelines like the CIS benchmark, which is a globally recognized best practice guideline developed by the Center for Internet Security. These guidelines and benchmarks played a key role in many challenges of the operators. Related to drivers, in most of the posts, the operators stated what motivated them to post on Stack Exchange. Only 50 posts did not provide any information on this. We were able to identify 6 different drivers. Fear of attacks was the most common driver, representing nearly 23% of the post. This fear was often a result of prior incidents. Operators had previously been hacked or wanted to prevent future compromise. The second strongest driver, with 70%, were external reasons. Many of these posts were motivated by regulatory requirements or the need to align with benchmarks. This leads us to one of the central contributions of our study, the challenges in system hardening. We identified 3 major question triggers: curiosity, assistance, and troubleshooting. Curiosity refers to high-level conceptual questions. Assistant refers to concrete help during implementation. And troubleshooting refers to resolving errors after applying hardening measures. Across these triggers, we identified 7 major challenges categories. We take a closer look into 2 challenges, starting with understanding or following a hardening measure. This challenge came up in 43 posts. Here, operators attempt to understand or follow a hardening measure, but struggle to interpret the instructions or reconcile them with their environment. Notably, 35 of the 43 posts explicitly referenced external sources as the reason for implementing the hardening measure. Most of these references were guidelines and benchmarks such as SIS. For example, in this post, the operator admits that he is not familiar with the Linux domain. He also says that he has to implement a task from a hardening checklist. And he also states that he does not understand the hardening measure. This is an example of how operators work blindly through checklists without really understanding them. The next challenge is misconception of a hardening measure. In this challenge, the operator implemented a hardening measure but did not understand its consequences. This frequently led to unexpected errors, which the operator did not understand. With 10 out of 19 questions, the most relevant security aspects were guidelines and benchmarks. Let's take a look at the following post as an example. Similar to the previous post, the operator states that he must implement a hardening task and executes several commands to do so. The operator then states that his SSH connection terminates after running the command iptables output drop. This example clearly shows that operators execute commands blindly without knowing the potential consequences. It also shows that operators configure firewalls when it's required as part of hardening without any knowledge about it. Based on the identified challenges, we make the following recommendations. First, about secure default settings. Many security issues reside from insecure default configurations. This forces operators to make complex hardening decisions, often without sufficient expertise. Therefore, we suggest that applications be shipped with strong secure by default configurations that can be downgraded when necessary. Predefined security levels and proactive default configurations reduce the risk of misconfigurations and lower the demand for advanced security expertise. Documentation is often insufficient, difficult to access, or poorly structured, creating significant obstacles to effective system hardening. This lack of clarity and completeness increases the risk of misconfiguration and inconsistent security controls. Clear, comprehensive, and user-friendly documentation that includes practical recommendations would substantially support operators in implementing secure hardening practices. It would reduce ambiguity, streamline configuration efforts, and strengthen overall system security. Introducing a dedicated security operation champion role, comparable to security champions in development teams, can help bridge the gap between abstract standards and concrete system context. This role would facilitate knowledge transfer, promote contextual interpretation of benchmarks, and strengthens the overall security posture. The key takeaways are: system hardening is widely discussed but purely understood in practice. Operating system and server application related issues dominate hardening discussions. Access control and guidelines and benchmarks cause a lot of trouble. And hardening is often driven by fear and external pressure, such as compliance regulations. And misconfigurations and blind benchmark adoption create recurrent problems. With that, I have reached the end of my presentation. Thank you very much. I look forward for your questions.
Okay, thanks, Nicholas. We've got a minute or two for a question, if you have one. Hi, Nicholas. Hey, I've got a question for you. So, yeah, appreciate the talk, and these recommendations make sense to me. They felt like they're recommendations, to the sysadmin human, maybe, ending up with this, have this role of a security champion. I'm wondering if you or others, now with AI coding agents making such a big difference in coding and taking away much of the task, is the future going to be AI agents are going to be, we can train them to do the system hardening and and the users will take a much higher level kind of a management role, or do you think, are these things very difficult to automate? Maybe at the moment, do we need more understanding, or just wonder what your opinion or experience?
Yeah, it's an interesting point. Actually, I'm not so into system hardening with AI, but when we look at what's possible for programming tasks, I think that basic system hardening will be possible with AI in the future. But yeah, that's maybe a good idea for next study.
Next year, come and do a comparison. Yeah. Maybe other than that, any other next steps, for your research? I mean, what's is there more research to be done, or do you think you need to take these ideas and just get them incorporated into real organizations? Or
I think there should be there should be some research done. Yeah, but actually, I'm not into this topic anymore, so I'm working on another topic.
Okay, yeah. So there's maybe a topic for one of you to, if you're interested in AI opportunities, maybe that's up there. So with that, let's thank Nicholas. Thanks, Nicholas. We're glad you were with us. So thank you.
Yeah, thank you very much. Have a great day, everyone.